Hey guys, welcome back to the channel. Today we would be solving the second question of weekly contest 436. So the question is assign elements to groups with constraints. So basically we are given two arrays, groups and elements, and we have to return a result array such that for every element in the group array we have to find the index of the smallest element, which is the divisor of this element. Okay, so for 8, 4 and 2 both divide 8, so the smallest index of the element is 4, so which is 0. For 4 again, 4 and 2 both divide 4, so the smallest index is for 4, which is 0. Great. Now here no one in this array divides 3, so the smallest index would be -1 because we didn't find any element which can divide 3. Similarly for 2 and 4 the answer is 1 and 0. Great. So here we would be learning an interesting concept of sieve of Eratosthenes. So let's see. So basically sieve is used to find prime numbers, but we can apply some modifications to the sieve to get all the divisors of a particular element, or let's say the first and last divisor. So let's see all the applications. Now what I'll do is I'll just maintain an array of elements, like let's say we want to find the divisors up to 10, let's say divisors or maybe prime numbers, let's say 10. Okay, so I'll declare an array of size 11 such that we will also have 10 in our array. Then we can have some facts, like let's say for an element maybe 8. Okay, for an element we know that its divisors would be less than this element, right? So the divisors of 8 would be 2, 4 and 1. Okay, so for every element we know that if this element is not a prime number, then its divisors will exist less than this element, right? So based on this fact we'll build this array. So this is the C. So first we'll just ignore this 0 and 1 because 0 can't divide any of the element here, and 1 will divide every element. So we will not check 0 and 1. Also we know that a prime number is a number which can be divided by 1 and itself. So let's start from 2. So for 2, no one have marked this 2, right? So we'll just mark it as 0. Now let's say 0 here defines that this is a prime number. Okay, so let's mark all the multiples of 2. So first we'll go to 4, mark it. Then we'll go to 6, mark this. Similarly 8 and 10. So now we know that 4, 6, 8 and 10 are multiples of 2. Great. Similarly we came to 3. Now as 3 is not marked, which means that no element is present which is less than 3, which is divisor of 3, which means this is a prime number. Okay, so again mark it as 0. Now let's again mark the multiples of 3, which is 6 here, but 6 is already marked, so I can leave this, and then I'll go to 9. So mark this. Now we can go to 12, but we are considering elements up to 10 only, so we'll just move forward. Now here we can see that 4 is already marked by 2. Now here we know that whichever element which is divisible by 4 is also divisible by 2, so we'll not consider this 4. Let's move ahead. Again 5 is not marked by anyone, so this is prime number. Again mark the multiples of 5, which is 10, but wait, it is already marked. Okay, so let's go ahead. So now here for 7 we know that this is not marked by anyone, so this is again a prime number. Let's go to its multiple, which is 14, but we are not considering 14, so we can leave it. So now we have this array. Now whichever which is marked as 0 is a prime number. These are the prime numbers, right? And for which the elements is marked, we can say that this is the first divisor of this element, right? So similarly we can get the next divisor by simply, like for 2 we are marking 4, 6, 8, 10. Now when we'll go to 3 will mark again 6, so we'll just replace this 2 by 3. We'll go to again 3, then for 9 we'll mark it as 3. Okay, so we'll go to 4, then the multiple of 4 is 8, so we'll replace this 2 by 8. Similarly for 5, we'll go to its multiple, which is 10, we'll replace this 2 by 5. So now in this manner we got the last divisor of this particular element. Like for 4, with the last element is 2, which is the divisor, and for 6 its last divisor is 3, for 8 its last divisor is 4, for 9 its last divisor is 3, and for 10 its last divisor is 5. Great. So we saw 3 applications. So the first application which we saw is if the number is prime or not. Then again the second application. So the second application is basically the first divisor of number, and then we saw the last divisor of a number. Similarly we can get all divisors of a number, right? How? We can just go to every multiple, and instead of replacing it, we can just store that element in the list. Like for each index we'll maintain a list, and we can just add the multiple in that list. Great. So in this manner we can pre-compute the divisors up to range. We can pre-compute the divisors up to a particular range, like here we did for the range 10. Great. So we can use this fact in our question, and what we can do is we can just iterate through this elements array from the start, and we will mark all the divisors. Hence for the first element we will mark the first divisor of each of the elements. Okay, so for 2 we'll again mark the elements from this array, and hence as we are going from left to right in our elements array, we will first mark the divisors which is having the smallest index, right? So we can just code based on this fact. So let's start with the code. So initially let's maintain the range of our sieve. So let's say the max, or I would say the maximum would be what, 10 raised to 5. Why? Because here the constraints are element can be up to 10 raised to 5. So we can just maintain the maximum as 10 raised to 5, and then we will build our sieve. Then what else do we want? Here it is asked that for all the elements for which the divisor is not present, we can return -1. So we'll just fill the sieve with -1. Great. Now we can iterate on each of the element of the elements array. So let's see, elements equal to 0 is less than, I'll just iterate here. Now for each element we'll check if it is already marked or not. So we can just say sieve of this element, so I'll separately store it. So we'll check if it is not marked. Okay, so it is not marked, so we can mark it. So we'll start from the element itself. It's a I equal to E, which is the element itself, and we will go till our element is less than what, our maxi, which is the maximum range, right? And then each time what we can do is we can just do I plus E. So what it does is, okay, so here it should be current. So basically this is the step where we iterate through the multiples. Like for 2 we'll go to 4, then we'll go to 6, which is plus 2 plus 2. In this manner we'll just iterate through its multiples, and then what we'll do is we'll just mark the sieve. If it is not marked, sieve of this current, or I would say I. If it is not marked, then we'll just mark it by saying sieve of this ith element equal to what? The current element. Okay, so this is the divisor of all its multiples. Here also it should be current. Okay, so in this manner we got all the divisors, like we prepared the sieve array, and then what we can do is, for each of the element in groups, we can go to that index and check the first divisor. Okay, so we can just go to, let's maintain a resultant array first. Okay, so this is the resultant array. Then we can just go to all the elements, and then we will get result of I. We'll just replace this result of I with the element from the sieve for this element, right? Great. So we got our answer here. Now we can just return the resultant array. We defined a maximum range, and then we initialized our sieve. Then we initialized it with -1, and then for each element in the elements array, we'll just mark all its divisors. So we'll take the element, and if that element is not visited, like if it is not marked, then we will go to all its divisors, and then we'll just mark them with this current element, like this element divides all its divisors, sorry, all its multiples. And then in the resultant array, we'll go to each of the multiples and check who is the one which is the first divisor. Great. Now we can just run this, and let's see if there are any errors. So why are we getting wrong answers? Okay, so here in the resultant array, we have to store the index. So okay, so I just stored the element here. Instead it should be E. So yeah, it gets accepted. Let's submit this. So yeah, it gets accepted. So thanks for watching, and subscribe to the channel for more such videos.